All right, in this example, we are dealing with both an amplitude change and a period change. And we're talking about cosine. We haven't actually graphed cosine yet, and so this gives us our opportunity. You do have the other note sheet that is on Blackboard that gives you the key points for cosine. They're very similar, like the x values are exactly the same as for sine, except now we're starting at 1 and going to 0, and then -1, and then 0, and then 1. And so there's a couple things that I need to know for this. First of all, I'd like to figure out what the period would be. If cosine of x has a period of 2 pi, and this 1/2 is going to double that period because when it's inside the function, it's the opposite of what you see is what you get. So it's doubling the length of my period. And then the period of this function is going to be 4 pi. Okay? And so I want to keep that in mind when I make my scale. So we typically have our 5 key points, which means we're really dividing a period into 4 equal parts. And so I'm going to want to make every other box pi in this case. And then I just want to make sure in the vertical direction that I'm going up to 3. So, that's not what I wanted. I need my graph here. Okay. So this is y equals 3 cosine of 1/2 x. This is what I'm graphing. So in the y direction, like I said, I need to go up to 3. So, and -3. And I want to fill up the graph as much as I can. And then we said since we have to cover, our period's actually 4 pi now, it's twice as big. So instead of doing pi over 4 here, I'm probably going to do pi over 2. So pi over 2, and then 2 pi over 2 is pi, and then 3 pi over 2, and then 4 pi over 2 is 2 pi, and then 5 pi over 2, and then 6 pi over 2 is 3 pi, and then 7 pi over 2, and then 8 pi over 2 is 4 pi. So I got my 4 pi in there. And again, I'm just counting up by 1/2 pi. And so the pi's just stay there, and then look at the fractions in front of it. This is 1/2, and this is 2 halves, and 3 halves, and 4 halves, and 5 halves, and 6 halves, and 7 halves, and 8 halves. And I'm going to do the same thing in the negative direction. So negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, negative 6 pi over 2, negative 7 pi over 2, negative 8 pi over 2. Now, I probably could have made my scale a little bit smaller. I probably could have stuck with the pi over 4, and that would have been fine. But I just, I think for the purposes here, I just wanted to show you how to count up by 1/2 pi's this time. And I wanted a whole period to fit on the right side of this graph. So cosine typically starts at 1, okay? And the way that I've labeled this actually makes this really easy. So typically the period's 2 pi divided into 4 equal parts gives me pi over 2, but I'm doubling that. So then every 4 boxes here, I'm sort of hitting the next key point. So we have pi, we have 2 pi, we have 3 pi, we have 4 pi. And notice I ended where I started, and this is 4 pi across. This distance is 4 pi across. And I can keep going with that pattern. And I'm just referencing my unit circle. The difference here is I've been physically stretched out. But notice how my graph doesn't actually look any different than it normally would. This is compressed, or I keep saying that, this is stretched. But my graph doesn't look any different because I chose my scale so that it would fit, it would fill up as much of the graph as I possibly could. Okay, so in none of the problems so far have we dealt with any sort of shifting left or right. Now with a trig function, this is called a phase shift. So we're going to graph sine of x minus pi over 2 over a 1 period interval. And the deal here is that now I have to think about my starting point being different, because it was always 0 and then pi over 2, or pi over 2 times whatever my period change was. I could figure out the next point. So now I'm actually starting in a different location. But just like all the other functions we've dealt with, this negative pi over 2 is shifting to the right because it's inside the function, so it's left or right. And since I'm subtracting, it's the opposite of what you see is what you get. So I'm actually shifting this to the right, pi over 2. And so since my period is the same length as it normally is, and my amplitude is the same as it normally is, I'm going to use the same scale that I originally used with sine, or I would use with cosine if I was graphing that, just sine of x or cosine of x. And that's, I'm going to go up to 1 and down to -1. I'm going to fill the graph. And then I'm just going to choose pi over 4 as my every other. So pi over 4, pi over 2. This is really the scale that I want to use, but I like to fill up my graph. And how do I find the scale? I take the period and I divide it by 4. And that will give me a baseline for what I should make the scale. Now, when we get to the next problem where we're, in the next video, when we're sort of putting a phase shift with a period change, then I'm going to want to reevaluate this. I want to use, this is the smallest unit I want to use, but I want to make sure, or that's the biggest unit I want to use, but there might be some values with the phase shift. I need a sort of common denominator between the phase shift and the period. And there's one of those problems on a problem set. It's actually number 2 on the problem set that I'm assigning for tonight. And on that, I might make a video just going over that one problem once the assignment's due. I want you to just be careful about creating your scale just by taking the period and dividing it into 4 equal parts. It's not going to quite work, because if you divide it into 4 equal parts, but then the phase shift is left or right a fraction of pi, that doesn't work well with the scale that you've chosen, then you're not going to have much luck. Okay, I hope that makes sense, and if it didn't, I apologize. All right, so pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And same thing in the negative direction. Sorry that the tapping is so loud, but the microphone is, I guess I could have used my ear pods so that the microphone was closer to my mouth and not on the iPad itself, and then you wouldn't hear so much of the tapping. But maybe for the next go around we can do that. All right, so normally we would start, this is y equals sine of x minus pi over 2. Normally we would start at 0, 0, but I'm going to start pi over 2 to the right. So this is my 0 point. And then from there, I'm going to count 1/4 of my period to get to the next point. So pi over 2 is away from pi over 2 is actually pi. And so from here, I'm going to go up to 1. And that was 1, 2, 3, 4 boxes. So I'm going to go 1, 2, 3, 4 boxes to get back to 0. And then 1, 2, 3, 4 boxes to get to -1. And then I can keep this going. So 1, 2, 3, 4 boxes brings me here to the y-axis, and 1, 2, 3, 4 brings me here to 0, and then 1, 2, 3, 4 up to 1, 1, 2, 3, 4 back to 0, 1, 2, 3, 4 back to -1, and we are good to graph this. To make a really good looking sine and cosine curve is not always the easiest thing. And they're just not, it's not just like quadratic, and they're not semicircles. It's sort of, it's more quadratic than it is a semicircle, but it's not easy to make a good looking graph here, so just do your best. All right, I'll see you in the next video where we're going to put everything all together. We're going to do 2 more examples, one of sine, one of cosine, with a phase shift and a period change and all that goodness all together. I'll see you in that video.